Hi all, and we're going to start in on chapter 7. Obviously we've got a couple of odd weeks coming up, so instead of trying to focus on getting a test done while I'm transitioning into a hybrid model with my middle school students and then MCAs are happening, for some of you I'm going to keep going with chapter 7, and what's going to happen is, from your perspective, not a ton is going to change. The MCAs are going to shift around when quizzes get posted. Basically, quizzes are going to be posted on Thursday and then due Friday, so that students who are taking the MCA on Thursday or Friday aren't missing any material. If you're taking the MCA, just take the quiz whenever it fits into your schedule. If you're not taking the MCA, hey, you've got an extra work day, focus on missing assignments or catching up corrections on my class or others. The only other thing that's going to change is obviously we have a short week this week, so you're going to have lessons today and tomorrow. Then you'll have a long break, again, chance to catch up on things. And then your quiz on 7.1, 7.2, then also 7.3 and 7.4 will all be on the 22nd, 23rd, that Thursday, Friday, as I said. So get yourself ready for notes, and we are going to get started. So chapter 7 starts with simplify and verify, meaning prove, trigonometric expressions. So a trigonometric expression is something like this, where you've got a bunch of different types of trig things here. And just like we would with polynomials or something else, we want to talk about ways to simplify them. So the first strategy that you are going to want to use is just to rewrite using sine and cosine. So, for example, here we have secant, cosecant, and tangent, and we can rewrite them. Remember, tangent is sine over cosine, secant is 1 over cosine, cosecant is 1 over sine, and cotangent is cosine over sine. So, a lot of these, that's going to be the first place you want to start. So here, secant over cosecant, I would rewrite this as 1 over cosine divided by 1 over sine. So I might even write it like division like this. 1 over sine, the variable stays the same. In this case, it's all x. Plus tangent, which is sine x over cosine of x. Now, the reason I've written the division like this is that I'm going to then change it to multiplying by the reciprocal, which is easier, I think, to see in this format versus this one. So then sine is in the numerator, sine x over cosine x for that multiplication, plus sine x over cosine x. Now, you'll notice that these are the same. So this is 2 sine x over cosine x, which we can simplify to 2 tangent x. So this is the simplified version of this unsimplified here. So this is the same as 2 tan x. That's one way to simplify. Another way is to use the identities. And if you recall from the unit circle, which said that x squared plus y squared equals 1, well, the x and the y are cosine and sine, so we also can say that cosine squared of t plus sine squared of t, they have to be the same value, they have to be the same variable, is equal to 1. Now, if I divided this by, let's say, sine, this also says that 1 is equal to, 1 plus tangent squared is equal to 1 over cosine, which is secant squared. And if I divided that whole first function by sine, it would say that cotangent squared t plus 1 is equal to cosecant squared. So these are your three identities that you can also use. You're going to use this one a lot because if you start by writing everything in terms of sine and cosine, which is what I recommend you do, then you're already going to be looking at the sine and cosine one. But sometimes you'll just recognize these and you're like, oh, I can just immediately jump to secant squared or something like that. So here we're already in sine and cosine, so we're going to add fractions. When we're adding fractions, that just means we need a common denominator. Now, the easiest common denominator is just to multiply them both by the other denominator. So 1 plus sine on the first fraction, and then times cosine for the second fraction, so that you get our new fraction, 1 plus sine theta times sine theta plus cosine theta all over cosine theta times 1 plus sine theta. Right, common denominator, add the numerators. Next, what I'm going to do is simplify the numerator. We can distribute, and I get sine theta plus sine times sine, which is sine squared, plus cosine times cosine, which is cosine squared, all over, and I always leave the denominator, just like I did with polynomials, I leave the denominator in factored form because I might be able to cancel out later. Now, here we have sine squared plus cosine squared, which, besides the commutative property where the order switched around, we know that that's equal to 1. So then in the numerator, I have sine theta plus 1 over cosine theta times 1 plus sine theta. And this is why we leave it in factor form. Cancel, cancel. 1 over cosine of theta, which in its most simplified form, 1 over cosine is secant. So again, we're simplifying. We have these added terms, and we end up with the simplified secant theta. Now, verifying, basically what this means is that you're going to prove that something's true. So what you're going to have is you have the unsimplified version on one side and the simplified version on the other. You know you're done when they look the same. So verify, again, this just means prove. So show that the equation is true. Now, one really important note is you can only change one side at a time. So for example, I can't multiply by tangent to both sides because that would say I know that they're equal. Can't do that. What we can do is we can simplify. We take one side. So in this case, I'm going to take the left-hand side, and I'm going to take this, minus cosine x over tangent, and my goal is to make this equal to sine of x by simplifying. All right, now, first thing I'm going to do is I've got a secant and I've got a tangent. I'm going to write them both in terms of sine and cosine. So 1 over cosine x minus cosine x over sine x over cosine x. Now, one thing you'll notice, hopefully, is that cosine is the denominator of both of these. So just like before, if you have a fraction in a fraction, you can multiply by the common denominator. And what that gives you is, if you write it out, cosine x over cosine x minus cosine squared as we distribute to the numerator. And then in the denominator, we've got sine x cosine x over cosine x. These cancel, this cancels, and what we're left with is 1 minus cosine squared x over sine x. Okay, we're getting a little bit more simplified. Now, here's something that we haven't seen before, 1 minus cosine squared. But what we do know is that 1 is equal to sine squared plus cosine squared. This is one of our identities. If I subtract cosine squared from both sides, I end up with 1 minus cosine squared, which is the same as what I have here, and I can replace it with what's left, which is sine squared. So using my identity, I can then say sine squared of x over sine x, and then this is sine times sine, so I can cancel out one of those, and I'm left with just sine of x. And remember, that was the goal, because of the transitive property, which says this is then equal here, which is equal, all the way down. So now I know that my left-hand side is equal to my right-hand side at the bottom, and that's the whole proof. To show that a proof is done, we draw a little black box after it. It's like a period in a math problem. One other thing that's going to be helpful to note is that if you have negatives in here, for sine, that means the same as the negative sine theta, so the negative jumps to the outside. Cosine of negative theta, the negative just cancels out because it's symmetric over the y-axis, and so the negative x versus negative y doesn't matter because they're perfectly symmetrical. Go work through these problems. There's going to be a huge variety of difficulty in this range, so pick ones that you think look interesting, that look challenging but not too hard. And of course, I will be available if you have any questions. Put them in the form or send me an email, set up a Zoom appointment, anything.